It was. By the way, what did we do Thursday? I didn't do a new lesson Thursday, did I? I didn't. I did teach it? I don't think I put it on YouTube, did I? Because I went.
You said you weren't going to record.
Oh, I said I wasn't recording it? Why did I say that? Oh, because we just did examples. That's what it was. Okay. Because I went back and I looked to see. I didn't put anything on any of my classes on Thursday, and I couldn't remember. That's another reason I'm a baby boomer, is because my memory is just terrible. So I definitely go with the older generation. All right, let's do this one. Let's find the area of other quadrilaterals. So the first one is a trapezoid. Trapezoid. So this is a little different. A little different. But remember what I've been saying this a lot. A trapezoid is really similar in a lot of different ways to a what? Even though a trapezoid's got four sides, a lot of things that we learn about a trapezoid is the same as is closely related to a what? Starts with a TR. Come on. A triangle. Okay, I've mentioned that a bunch of times, I think. Apparently not enough because you didn't remember. But anyway, it's very I don't know. Just use the word and I forget it already. See how terrible my memory is? It's very similar to a triangle, all right? So the area of a trapezoid is very similar to the area of a triangle. So what is the area? I'll just put TRI. Is that all right? For triangle. And this trapezoid would be TRAP. So the area of a triangle. Remember what the area of a triangle is? What is it? 180. What? The area of a trapezoid is 180. That doesn't make any sense. I know what you're thinking, but that's not what I'm asking. What's the area of a triangle? Off the top of your head, you should know it. Base times height, what? Divided by 2, or half of it. You could put a half in front of it, or you could put it over 2. That's the area of a triangle. The area of a trapezoid is very similar to the area of a triangle, except the area, or the trapezoid has how many bases? It's got 2 bases, doesn't it? So, how many heights does a trapezoid have? It's got 1 height. It's got the same height because these 2 lines are what? Parallel to each other. Very good. All right. So there's a trapezoid right there. It's got 2 bases. We'll call that base 1. We'll call that base 2. But it has just 1 height. Where is the height? It's from anywhere on that top parallel line, what? Perpendicular to the other base. Okay, so it's perpendicular to the 2 bases. That is your height. You only have 1 height on a trapezoid, but you have 2 bases. So take a wild guess, without even knowing anything about trapezoids, take a wild guess on... Actually, in my notes, I have a little proof here, but since I've been talking too much, I only got 5 minutes anyway. I can't believe I talk so much. That's all right. We'll finish up tomorrow, so it doesn't matter. Take a wild guess what you think the area of a trapezoid is. So area of a trapezoid is, it's kind of like this. It's kind of like that. Except, I gave you a big hint. The trapezoid has 2 bases. Triangle only has what? 1 base. So what do you think I'm going to do with those 2 bases? Add them up. Exactly right. So here we go. This is how they usually write it. They don't usually write it over 2. On a trapezoid, for some reason, they put the 1/2 in front of it most of the time. All right? And then what we're going to do, it's 1/2 the base. But it doesn't have just 1 base. Which one do we pick? The biggest one, the smallest one? No. Both of them together. So what do I do? B what? Come on. B what? You could say B2, but let's go 1 first. B1 plus what? B2 times what? The height. And there it is. That's the area of a trapezoid. Okay? Due to time, I am going to skip the example. You can look at it in the book. It's really straightforward. There's nothing to it. They give you the height. They give you the 2 bases. So what do? You add up the 2 bases, right? You multiply it by the height, and then you divide it by 2. So it doesn't matter what order you multiply those things in. You could do it like this. You could go base 1 plus base 2. Let's put it in parentheses. Times the height divided by 2. You could do it like that, couldn't you? It's the same exact thing. Dividing by 2, multiplying by 1/2 is the same thing. All right, so you could write it like that. But the thing in the box is the way most books would write the area of a trapezoid. All right, but you could write it like that. It's the same thing. All right, let's go to, what's another quadrilateral? A kite. Let's go to a kite. Now, this one isn't quite as intuitive. All right, let's draw a kite. Let's do it quickly. So I got a couple minutes left here. That looks close enough. And may not be perfect, but that's okay. I do want to put this line right here. Do you remember what we call that line? I wasn't exactly perfect on this, but that's okay. I'll do this. It's not the mid segment. I'm trying to remember myself, tell you the truth. Anybody remember? I know this is the crossbar. Remember that? They called this thing the crossbar? The yellow one. What did they call the yellow one? They gave it a special name. Forget what it is. I guess you could call it a diagonal. Both of these could be considered diagonals. But I think they gave this, on a kite, they gave that a special name. And I forget what they call it. Pretty sure they call that a crossbar, but it doesn't really matter. So here's what's kind of interesting. Let's call the yellow one D1, diagonal 1. Is that all right? So what do you think we're going to call this red one? Good call. D2. Everybody got it? So this whole thing is D2. I put it up here, but the whole entire thing is D2. Everybody got it? The whole red one is D2. The whole yellow one is D1. What do we know about... What do I know? I'll tell you what. I'm just gonna show you what it is. I was gonna, just because of time for the most part, I'm just gonna tell you what the area is. So the area of a kite, it has to do with the diagonals. That's why I put the diagonals in there. Okay. And what's true about the diagonals of a kite? What do? They are what? Perpendicular. Okay. Remember that? And here it is. It's 1/2 D1 D2. So you multiply the two diagonals together. So if you know the lengths of both of those diagonals, you multiply them together, and then you just take half of it. Couldn't be easier, could it? Again, the example in the book is really straightforward. It's not that big of a deal. The nice thing about the third one, what do we say the third one is? Rhombus. The nice thing about the area of a rhombus is it's exactly the same as the area of a kite. But let's draw it and see what we have here. So the rhombus looks like this. Bell's about to ring, so just give me a minute. And I'm not going to change colors just because of time. But watch. This one and this one. Are they necessarily equal to each other, those diagonals? No. So one diagonal would be D1. That'd be the whole entire thing. All right, everybody see that? From here to here. And this other diagonal we'll call D2. Even though I put it up here, it means it's the whole entire diagonal. All right? And the area of a rhombus, we'll put rhombus, is equal to the same thing as the area of a kite. So what is it? 1/2 D1 D2. That's nice, isn't it? Don't have to remember another formula. And let's see. Yeah, example 4 is a little tough. Example 4, they put some ordered pairs, right? So they do that coordinate geometry. So they give you this one, this one, this one, and this one. And they ask you to find like the slopes of the diagonals, the length of the diagonals, and all that kind of stuff. And then you can find the area of the whole entire thing, all right? So we pretty much finished it in what? Less than 10 minutes probably. All right, so that was nice, wasn't it? So your homework is whatever I told you on the lesson plan thing. Let's see, what is it? 1 to 14. So you're doing 1 to 14. So 1 to 14. That's your homework.